scholars, I just wanted to do 2 of the ladder homework problems so you can use that as a guide to help you and for extra help. We're going to look at problems number 36 and number 38, where you are asked to write the standard form of the equation of the hyperbola, and then I change the directions to find just the center and vertices, and then to sketch the hyperbola. You do not have to worry about the foci or asymptotes, and you don't have to worry about verifying it with your graphing calculator. So, my friends, let's look at number 36 first. So, all right, at number 36, you're given this equation, x squared minus 9y squared plus 36y minus 72 is equal to 0. Well, the cool thing is we group by variables, and they're already grouped for us. So we're going to go x squared minus 9y squared plus 36y. Make sure I got here my 36y, and I'm going to do full screen here. Equals, and we move the constant over, just like we do with any completing the square. Notice there is no other x to the first variable, so we do not have to worry about doing completing the square with x squared. But now I need to specifically look at my y. I need a positive 1 in front of the y squared, so I factor out a negative 9 with my y terms. So that gives us y squared minus 4y. We're going to go a plus blank here. We're going to go 72 plus blank. So then we are going to do completing the square inside the parentheses. So we take a negative 4, divide by 2, and that gives us a negative 2. Negative 2 would be squared is 4. We multiply the negative 9 to the positive 4, and that gives us a negative 36. So that is what I actually add to the other side, so negative 36. Then we finish up combining like terms. So we get x squared minus 9 times the quantity. Now we're going to do our binomial squared, so it's going to be y minus 2 squared, which equals 36. And then we divide everything by 36. So we get here x squared over 36 minus y minus 2 squared all over 4 is equal to 1. So this is standard form. I can quickly find my center because remember, h goes with x, k goes with y, and so that's going to be 0, 2. All right, so now we have the center, but now we need to graph and find the vertices. And if you actually graph and find the vertices together, that makes your life a lot easier. So I'm going to put my axis here, and then we are going to graph our center, and I'm going to do the graphing the center in, if I can. It does not want to change colors here. Let's do that one in red. So we're at 0, 2, and then we find our vertices when you're working with this by using a. So we know a squared is equal to 36, so a is going to be plus or minus 6. Now, since the positive 1 gives us our a, it also tells you we're opening to the left and right because the x squared is what's the positive 1. So we're going to go to the right. 6, 1, 2, 3, 4, 5, 6. For a vertex, we're going to go to the left 6, 1, 2, 3, 4, 5, 6. Here's our vertex. And then all we need to know is, so really, remember this is a distance of a. And that's where we get our vertices from. So let's write them down. Our 2 vertices are going to be a negative 6, 2 and positive 6, 2. All right, now we just have to use b to make our box, or let me box that before. All right, so b squared we know is 4, so b is going to be plus or minus 2. So I have to go up 2, down 2, and then we make our box that we're going to draw our asymptotes in. Remember, the box will have the vertices and our other 2 points here. Then we draw the asymptotes diagonally across, and yes, those of you who use in the ruler, you know you're going to do a better job than me. And then we draw in our two hyperbolas, touching the vertex and getting close to our asymptotes. And those is your hyperbola. All right, let's do number 38. Let's crank these out, right, my friends? Okay, number 38, slightly harder, but still a good idea. We get here 3y squared minus 5x squared plus 6y minus 60x minus 192 is equal to 0. Okay, let's group our variables together. I'm going to put the y first because it has the positive coefficient. So I go here 3y squared plus 6y, and then I'm going to go a negative 5x squared minus 60x, and then I'm going to move my constant over. All right, now we have to think about, again, completing the square. So we want to have a 1 in front of our squared terms. So I look at the first ones here, and I factor out a positive 3 because that's what's in front of the y squared. And for some reason, it wanted to change on me. So we go 3 times quantity y squared plus 2y, and we're going to go plus blank. And then this one, we have a negative in front of 5 in front of the x squared, and that's what has to be factored out, a negative 5. And that gives us x squared minus 12x, plus 12x plus blank equals 192 plus blank, because we have to do it for both of our completing the squares here. Okay, so let's do completing the square. Divide 2 by 2, it's 1. 1 squared is 1, so we multiply by 3. That gives us a positive 3. 12 divided by 2 is 6. 6 squared is 36. We're going to sit there and we're going to distribute the negative with that, and that's going to be a negative 180. Okay, so let's do our math real quick. I do believe this is going to equal 15 on the right. And then we're going to have here 3 times quantity y plus 1 squared minus 5 times quantity x plus 6 squared. So we just did the completing the square there. Remember, to be a hyperbola, though, you must equal to 1. So we're going to divide by 15, divide by 15, divide by 15. So I get the quantity y plus 1 squared all over 5 minus the quantity x plus 6 squared all over 3 is equal to 1. So this is the standard form. Okay, now let's pick out the center carefully. Remember, the k goes with the y and the h goes with the x. So our center actually ends up being a negative 6, negative 1. All right, so we want to graph this when we're working with it. So let's put in our axes real quick. Partly because I do not want to think too hard about it, right? I'm going to keep going here. Okay. All right. So with this, let's put our center. We got negative 6, negative 1. So 1, 2, 3, 4, 5, 6. Negative 1. Then we have to find our vertices. Okay, our vertices, how do I know where to put them? Remember, it goes in the direction of the variable that is positive. So vertices are going to go up or down. So we're going to go up and down from the center. So here's the center, but how do I calculate that? Well, I have to solve for a first. So we're going to go a squared is equal to 5. So a we know is plus or minus the square root of 5. So that means I have to go up the square root of 5. Well, some of you are like, well, I don't know how to accurately do that. Well, guys, just get a rough estimate. The square root of 5 is 2.23. Okay, close enough. So I have to go up root 5, and I have to go down root 5. Why did I know to do that? Because y is the positive term. It is the one that a squared is under, okay? So I had to go up a, and I had to go down a. So I moved vertically. So I move with the y. So it's going to be -6 is going to be -1 plus or minus the square root of 5. I don't know if you guys can hear my sharp little dogs barking right now, but she's going berserk. All right. Now, those are our vertices. Left to graph, we just have to use b. Well, b in this case is going to be the square root of 3. Well, what's the square root of 3? Well, that's about 1.7. So I'm going to go 1.7 the opposite directions, so horizontally for each, and then we draw in our box. And we can go, okay, here's our box. And again, guys, someone's like, how accurate do I have to be? Guess what? Good enough. All right, let's draw our asymptotes through diagonally, through our corners. Wow, that's really bad. Don't use that one. And through our center. And then we just graph. Remember, this one opens up and down because y is first. If x was first, it'd be left, right. So we just go through, we touch our vertex, go up with the parabola, we touch our vertex, and we go down. Hopefully that helps you on number 38, my friends. I know that one was a little bit more difficult, and number 36. And guys, I hope if you have any questions, please don't forget to call as well. All right, guys, know your love.